All right. Okay. My name is Kush. I'm a software engineer. My background is film, animation, game dev, and industrial design, and so on. But money-wise, like software is what comes easy or fun. For the last few years, I've really been exploring AI in terms of clients as well as just experimentation. So today I'll talk about open source AI especially, and I'll get into it why. So I think I already talked about myself enough. So AI, obviously a massive umbrella. There's lots of stuff under it. There's been a field that's been around for many years. But right now, one of the ways that you can think of AI, especially the sort of subdomain of AI that I'll be talking about, is these tools, these models that you can use to transform one modality into another, or one piece of data into another. So for example, you can think of text converting into voice, that would be text to speech, generating voices from different people. Speech to text, that's transcription, so being able to understand what someone is saying without having to listen to the whole podcast or something. Text to text, which is like, of course, translation, or text to text generation. So ChatGPT, you give it a question, it gives you an answer. Same thing with text to video, like models that can produce an entire GIF or a movie from text, etc. So basically, you can think of the intelligence that allows you to automatically, not through a human, but automatically go from one modality into another, or even the same modality to itself, but changing it. That's what the subdomain of AI is that I'm very interested in, and that I'll be talking about. Give me 1 second, let me open up my timer so that I don't run off way too much. Okay. So within that field of AI, I'll be focusing on NLP today, because I do personally have a sort of longer love for computer vision and computer graphics in general, and the AI aspects of it. But for the last few years, especially with LLMs and transformers, the architecture, NLP has been a big focus of mine, just using NLP artifacts for various projects. So before I actually get started, I want to just quickly survey the audience. How many of you have used like large language models outside of the context of ChatGPT, the app? Awesome, some developers here. All right, perfect. So I'll generally speaking, I will introduce these things, but I will get into some really fun stuff that you can do with them as well. So while some of this might be very introductory, you will find the value in sort of some of the niche stuff towards the later part of the talk. So NLP, the two aspects of this field, the artifacts of this field that I'm going to talk about are LLMs and embeddings. LLMs are the large language models, which you have been hearing about a lot: ChatGPT, Llama, Mistral, all these models which you can use to input text and output under the form of text that's somehow useful to you. And embeddings, I'll get into later, is another very cool artifact, something that's been around for a while actually, before even ChatGPT, but I didn't know about it. I only found out about it after, and I'm like, wow, this is extremely useful. So we'll get into it later. So let's talk about LLMs. What are LLMs? How did they get here? So you can think of LLMs as fundamentally knowledge compression. So really what's happening is you're using a process of training to compress trillions of tokens. In the latest case of Llama 3, the open source model by Meta, which I will be using throughout the talk to demonstrate stuff, it's viewing 15 trillion words, or almost 15 trillion subwords, which is basically the entire internet, somewhat. It's looking at it and it's training on that data to compress that into a few gigabytes of data of a file. So you can think of these LLMs as a file that simply compresses this massive amount of knowledge in a lossy way, but in a way that it forms an understanding of what's going on. So the way that it would be trained is, for example, you would give it like this much data, this whole sentence, and you would say the next word that you should predict, hey model, should be deeper. If you don't predict deeper, then I'll give you like whether you're off by a little bit or a lot, and you go ahead and try again. And the same thing happens again. After deeper, it should be high. After high, it should be highly. After highly, it should really be recommended. So this is the mechanism through which these models are trained to be really good at the prediction of the next word. And that's really all that's happening, fundamentally speaking, in these LLMs. It's just models getting trained to say the word face when they see this whole context with the end word familiar. They're just going to say face. So this is next word prediction all the way through. That's really what LLMs are about. compression of knowledge, and now you have an entirety of the world represented in these small files that you can extract knowledge out of, extract semantic understanding out of. I had another thing I wanted to say. Moving on. So let's get into base models. Let's talk about how they actually work, how they were trained, and so on. So in a base model, the artifact that this extremely expensive millions of dollars and millions of hours of compute produces, the base model, let's say the Llama 3 8 billion parameter model, or the 70 billion parameter model, in this case 8 billion, it produces this file where you can prompt and get some responses back. So if you go ahead and prompt with the word once upon a time, phrase once upon a time, and you ask for a response, it's going to say there was a little girl who lived in a big house. That's the response. If I try it again, it'll say the same thing. Why? Because fundamentally this model has learned that after once upon a time, comma is the most likely word. After that, there is the most likely word, and was. It'll always say this deterministically. But you might wonder, like, how come when I ask ChatGPT questions, it comes up with a different response each time? I'll get into that in a moment. But same thing here in a land far, far away. Same answer every time. Now, of course, if I change it, if I say once upon a time, then it might change the answer because I certainly added a different variable in here. So let's go to the next slide. So how is this working? The next word prediction aspect, we just dive a little bit deeper and then I'll zoom out. So really what's happening here in terms of the prompt response mechanism in these models is when I say once upon a time, it simply produces one word. What's the next most likely word? As I said, in its training, that's what it was trained to do. That's what it's going to do now. Once upon a time, comma is simply the most likely word. All right, there's the next likely word. Was is the next likely word. And what's happening here, why are you seeing the word here, is because really the way these models work is whenever they come up with a response, let's say was, I copy that word, I put it right back in the prompt, and then I run it all again. Same thing again, there was a little girl. I go ahead and copy the word girl, and I ask for something else. Maybe I change it to boy, and ask for something else. But the point is, it's called autoregressive, this mechanism, which means it simply needs the output that it previously produced, and it iterates over that. And literally nothing more is going on, in terms of the mechanism of it. There's a lot of magic around these technologies, but fundamentally, it's just predicting the next word. And there's lots of debate online about how much intelligence is really contained in these models, but fundamentally, that's what it's doing. So, for example, if I say, the quick prime fox jumps, it's seen that sentence so many billions of times on the internet, it simply is going to do that. Same thing with, the field of natural language processing is the most likely thing. So let's talk about the temperature aspect now. The thing where, how come when you ask ChatGPT, it seems to come up with a different answer each time? It's because instead of saying, give me the next most likely word, once upon a time there was a little girl, actually go ahead and don't pick the most obvious likely word. Give me somewhere in the range of the likely words. So that means there's a whole mathematics around it, using log probabilities that does some multiplication, and the temperature is one variable in the middle of it. But let's say a high temperature generally goes from 0 to 1. What does it produce? Boy, okay, it's sort of switched it over. Let's say I say it was the field of natural language. So natural language is the most likely word, but if I go ahead and actually increase the temperature super high, then maybe it has a chance of saying something different, natural science is. Here's a funny one. If I say the field of defense against, almost certainly it's going to say the dark arts, of course when the temperature is 0. But even if I go ahead and change the temperature to 1, it's just so extremely likely that the defense against the dark arts is the next most likely word that it's going to stick to it. And this is why even if you have a high temperature in these models in ChatGPT, you can get a lot of use out of it because it will maintain the fundamental premise of, like, when you say where are you going is just like such a likely word next that it won't mess up that part. So you can still have the temperature higher and find a lot of utility in it. So that's kind of, and by the way, the model I'm using here to demonstrate all this stuff is Llama 3 8 billion. This is the open source model, just came out a few weeks ago. Awesome stuff. I'll talk about why it's awesome in a moment. So let's talk about how we build up on these base models and actually get all this utility out of it, like the applications you've seen around you, and especially since the ChatGPT app and what it can do. Because the base model seems to always just predict the next word. How do you go beyond that, right? So for example, if I say translate the following sentence to French and I hit enter, actually it didn't do that. Kind of like just went on a whole thing, like just paragraph like it would see in the world. Same thing again, I'm going to try again. just arrange the words in a different order. So it's kind of like just completing the document it's on, like, or an idea of a document, but it isn't actually doing the task for me. So, okay, well, if it can do that, if it has some understanding that it's just trying to complete a document that exists in the Word, well, I'm going to go ahead and pretend as if the document is giving it instructions. So it's saying translate the following sentence, English this, and then I'm going to put French colon. It's very much more likely now to actually finish it because it sees the word French colon, unlike here when it doesn't see that. So now it's going to go ahead and fit it. And don't worry about whatever you're seeing after. I'll talk about how we can handle that and trim it off. So now this is called one shot, or not quite, but let's say, for example, we do this and we give it one example. You know what, when I say French for hello, how are you, you do this. So if it's a beautiful day, you might do something else. So this is called one-shot prompting. If you've heard that word somewhere online and you what are these words, fine-tuning and one-shot and so on, that's one-shot prompting. Same thing now, if I say classify the sentiment of this movie, it actually wrote me some code to try and do that. That's not what I wanted. I wanted to actually classify this. Sure, so I'm going to say put sentiment after it, and here's an example of a previous one. So much more likely to actually get it, right? So this is few shot, whatever. So these are all just examples. And I would talk about like how this sort of novel insights came around with the published in this paper, language models or few shot learners and a bunch of other stuff. But this talk is sort of supposed to be an hour long or 3 hours long. So I'm just compressing a lot of knowledge in this moment. But let's move on from this. So yeah. So for example, we understood how we were doing few shot prompting just now. Like again, if you ask a regular question versus if you give it some understanding, it works. But let's say we want to actually have a structured way to do this so that we can use code to manipulate this stuff. Then we might say, you know what, we're going to come up with a format where we say, whenever you see question, answer, like this is the way you're supposed to do. So next time it sees question, we'll just trim off the sentence and we'll keep the part that it generates after this. So we're going to see whenever this question appears, we're going to trim it off. All right, that's kind of a workable solution for me to be able to just get that answer. But what about this? Let's actually make it this way. So when you see instruction and closing instruction tag, when you see response and closing response tag, that's actually how you generate it. So now if I ask it for a response to what is the user persona, and I see the word, / response, I know that's the end of it. So I can just stop generating at that point. That's a great way for me to just cut it off. That's really what's happening in most of the applications. To actually know what was the meaning, what was the actual response that the LLM wanted to give, and anything after that, we just simply stop generating or ignore it. So we just discussed how that stuff, how that prompting can happen. But of course, there's standardization as we go, further into these fields. A lot of people are trying different things, and they come up with great ideas, and those ideas get popular. So one very popular format, this is last year after Llama, the original one, got leaked and people started playing with it, was the alpaca format. Alpaca format was one basically where they would say, here's the sort of general overview of what we want to do. Below is an instruction. It describes the task, do it. Sort of markdown style, here's the instruction, here's some context for it, input, and here's the response, and we leave it empty, the next line. So we say convert from Celsius to Fahrenheit, temperature in Celsius is this, and it will go ahead and generate it. So this is a popular way to format that, unlike kind of like question answer or whatever, right? So same thing, one of the popular ways was this, format was this is called chat ML, where you have sort of instant message start and instant message end, and you sort of specify who's the message from, system or user or assistant, and then it'll sort of complete it. So it's just the same idea, just doing it differently, more useful for parsing, because the words I am start with this sort of open bracket is much less likely to appear in the user's actual question, so it won't get confused. While the word question itself might appear in the user's question, and then kind of things get messed up. So, and then there's another format now, beginning of text, start header, because there's a million formats, everyone's got to come with their own, that the Llama 3 model came up with. So Llama 3, 8 billion instruct. So what's happening here, just to sort of preface it, is fine-tuning was when we went ahead and took these pairs. Instead of just prompting like this, we prepared, like, let's say 1,000 examples with this question or this kind of question and a response that's appropriate, or 100,000 pairs of prompt completions. And we went ahead and trained the model further. That's called fine-tuning. The initial training was called pre-training. This one's called fine-tuning. I guess training never really happens in that grammar. But the point is, you give it 100,000 examples of this kind of a format, instruction, input, response, instruction, input, response, and it just kind of adopts the mentality that whenever it sees instruction, it's going to do response. And you don't have to worry about it's kind of messing it up. So that's how it goes ahead and actually embodies that now. So instruction-tuned models now, I can say whenever it sees this format, beginning of text, system says you are a helpful assistant, user says define the user experience as a term, it's going to go ahead and just respond. Please tell me it's working. Okay, it's working. Sorry for my demo broke. Okay, so yeah, so now if I say classify the sentiment of this movie, answer with one word, positive, negative, like this is a very verbose, human-like instruction, unlike the previous ones where we were trying to structure it, it'll go ahead and do it, negative. So it just knows to follow instructions because now fine-tuning has embodied that style in it. So same thing with conversational AI. Basically, it was given multi-turn examples. So instruction, response, further instruction, further response, and then it just went ahead and adopted that mentality. So now if I see the thing, if I come back and I add, copy this whole response, put it back, add another user message, hit enter, it'll just keep doing that. Conversational AI is basically the same thing. It's just following the, sorry for the mic variability. Anyway, let's go forward. Yeah, I'm going to skip some slides here. So moving on from the general understanding of how these LLMs work and how the fine-tuned models, instruction-tuned models come about, how do you actually get a lot more utility out, especially the open source ones? And this is the thing that I'm most passionate about, is structured data from unstructured. That's kind of one of the key uses of LLMs that just, you can take them and just run with it to so many directions. So for example, if I ask, hey, you know what, extract all the names of people and stuff and achievements from this document, and I give it a document, Dr. Sarah did this, blah, blah, blah. I ask for it, it'll do a decent job. It'll come up with a sort of nice little, document describing all this. And this is kind of useful in a general context. But let's say I'm actually writing a software application. This is still pretty human language, not very obviously parsable by a piece of software, unless it's another language model. So instead, I'm going to say, go ahead and extract the names, but how about you give them back to me in JSON? And here's the schema that you should use. Each object should have a name, profession, location, achievements should be an array, and then I'm going to ask back from it, actually gives me a JSON array back. So this is awesome because as programmers, we can use that JSON immediately anywhere. And I have a lot of fun with it. For example, I can say, go ahead and extract the people from this document and actually pipe them into a UI immediately. So I can just do a dynamic UI being shown instead of sort of in some language that just you endlessly read and forget. Same thing again in this example, I go ahead and say, take those landmarks that I'm asking you for, basically what should I visit in SF, and actually show them in a UI. So you can imagine a dynamic Google Maps UI driven by an LLM. And generative UI is an extension of this, but this is dynamic UI, I would say. Okay, it's done. This is an example I can skip over. Basically, you can do regular expressions, not just JSON response, so you can really constrain the response to a very specific thing that you think you want from it. So moving beyond that, now that you have the ability to constrain the response to JSON or regular expression to any string, you can then say, you know what, I have a few different tools. Make sure whenever you respond, only use responsible of these tools. So if I say, what time is it? Don't say, here's the time. Give me a tool call to that tool. So for example, I gave it get current time, get current date, get current weather, get current value of stock. If I run this and I ask, what is the time right now? It's going to just say tool calls, name parameters, just a JSON object. And I can use that to call my own function, which should be obvious to any of you how to do that. Same thing, so what's the weather like? It's going to call the weather function. If I say, give me the stock prices of top 5 companies, it's actually just going to use its own internal knowledge to call the get current value of stock with 5 different parameters, right? So this is kind of using some of the internal knowledge of the LLM as well, mixed with the tool use. Another tool use example I'll skip over. And then lastly, coming to embeddings, the other topic in NLP. Extremely useful, extremely powerful idea. Basically what this is doing is, the idea of the embedding model or generating embeddings is to take semantic text or just general text, paragraphs, words, entire books even, but let's just say paragraphs, words, or sentences, and we go ahead and put them in a physical space, or not a physical space, but in a high dimensional space, like let's say a 3D space, but imagine a 300D space. And we just put them in that space using a sort of a transformer, that a hashing function almost. And it goes ahead and what it does is puts similar stuff next to each other. So for example, when I say Raspberry Pi stuff, it seems to put it in the physical space. By the way, this page is dynamically being generated every time I come to the slide. So this is all happening live. So it happened to put these words together, these sentences together, which happened to be about Apple, MacBook, and so on. These one happen to be about apples and fruits. happens to be close together. This is extremely powerful because you can now say, what's the nearest neighbor of sort of fruits? And if you go ahead and pick sentences. So if I say, for example, I have this movie database that I have built, I actually have built it, it's backing this slide, that has about 100,000 movies from Wikipedia scraping and so on. And I give it this sentence, and I just say, put this sentence into the high dimensional space and see what's near it. And the sentence says, a hacker discovers his reality is a simulated illusion and joins the fight against present machines. Seems pretty similar. You can imagine what movies it's probably close to. All right, I'm going to hit enter. It's going to run it. It's going to see what the closest ones are. Found Hacker Wars, found Matrix. Awesome. So we can imagine, it's not actually saying if this thing is part of that text. It's saying near it, walk around, see what the most obvious closest neighbors are, and show it to me. Same thing here. If I say, on world, loyalty, family's descent, it's going to go ahead and pick The Godfather as one of the results that it finds. So literally, it's just clustered, or not even clustered. It's just in the neighboring space. Go ahead and find those concepts. You can do similar, like you can do addition, subtraction, division, and so on to actually find the opposite or much farther away concepts, all kinds of cool stuff. And the final thing on this topic, now combining embeddings and LLMs, you have retrieval augmented generation, which I'm sure you've heard RAG as like the endless sort of term that you've been hearing as the best use case for LLMs right now. And basically what that is if I say, give it like a question. Hey, what are the key similarities between Inception and Tenet? As a question, it might use, let's say, tools to pick that movie, pick that movie's details, Inception and Tenet, by saying get movie details, Inception, get movie details, Tenet, like the tool use example. It would go ahead and put them into this context. Hey, answer this question only using this context, with the Inception thing, with the Tenet thing, and I run the assistant, and now it's going to go ahead and try to actually keep the answer, forgive the UI, but try and keep the answer specifically to what it's supposed to be. Which is a very awesome utility, because if you have personal data that you don't have like any assumption, any reason to believe that the LLM was trained on, you can give it your own custom data. Hey, you know what? Answer this question based on my own personal notes, based on my own company's data, and just respond back with that. Yeah, and then generally speaking, for now, that's about it. Thank you very much. And if you want to connect with me on LinkedIn, please let me know. I'm actually going to do a workshop, a longer workshop, like 3-hour workshop, I think, somewhere, possibly the VPL. So if you want to join that or something, connect with me and let me know some interest so that I can let you know when I do it. Probably going to be in the next month or so. Oh, any questions, please? Don't be shy. I'm extremely nice.
Can you explain the term temperature?
Absolutely, yes. So temperature is basically one of the dials, one of the knobs that you have when you're working with LLMs to be able to say, do not always answer deterministically. Generally speaking, these models will always produce the same response given the same input. But temperature is saying, the word that you were going to say, actually don't say that word. Here, fine, because what it really does, by the way, this is actually an awesome question. I'll get into some details. The way that these models work is there's a vocabulary for each LLM. Let's say for the Llama 3 billion parameter model, it's like 30,000 words or subwords, because there's obviously more words than that, but it's like half words, etc. And what it does actually with each time that it generates the response, the completion of the one single word, it doesn't actually give a word. What it gives is a probability distribution. So it gives a probability distribution over the entire vocabulary of 30,000 words. So it says, so if you look at that distribution, you'll see the most likely word after a familiar is space, but the second most likely will be familiar times, or extremely unlikely is zebra. So it'll actually say, you know what, one of the algorithms that you use for temperature is to say, get the top T, which is like a top percentage, top 25% of this probability distribution, go ahead and multiply with a certain number that you gave, 0.5 or divide by 0.5, etc. Run this softmax operation. I am so not good at math and stuff, but I do understand some of the formula that you use for that. And go ahead and, out of those 5 words that you found, pick the one that you think in this moment, or just pick at random. So that's really what's happening. The temperature is simply just saying, don't give the obvious right answer, mess around a little bit.
Can you get Greg to show you the source references?
The awesome question as well. So RAG is, again, retrieval augmented generation, which means really there's a few things going on there. Retrieval is finding what context should you give the LLM before you answer a given query, which is the whole field in itself. Augmented generation is, hey, now that I have some context, augment the generation with that instead of just generating the way that LLMs will generally respond. So to your question, can you add citations? to these generations? Well, yes. So the citation part really happens in two different ways. One is when you actually fetch the context to give the answer. So, for example, if my question is, "Hey, is it gonna or which company is leading the the tech industry?" And this is for a dumb question, I don't know, something like that. Let's say what drama is OpenAI been up to lately? It'll go and search Twitter or Google for like articles. Let's say it comes up with 10. It'll go ahead and embed them, or let's say it'll fetch the articles. It'll go ahead and give the LLM this context. It'll generate the answer. And because we know which documents we gave the LLM for the answer, we'd already have at least those 10 links. Then we can run a separate process if you're trying to be clever and say, try and match the text that you responded with the documents and see which one you used, because like a secondary layer. Because these LLMs are free, especially if you're using open source, which maybe I'll talk about open source a bit. You just have free compute. Just run it, and it'll go ahead and tell you exactly those two documents is where I got the answer from. So you can just link them, and that's really how Bing used to work before ChatGPT started doing that and so on. Yeah, thanks for the question. And just quickly on the open source side, like again, yes, you can do like a lot with ChatGPT, the application, but the true power here, as I'm expressing, is LLMs and embeddings as just ingredients, just like JavaScript, web browsers, Docker and so on. It's just a tool you can use on your own computer, extremely small, few gigabytes. You can even run this model called Phi and a few other ones on your phone. I'm always building applications for my phone that run locally, and that also means that you can actually launch applications that you never need a server. You just like through decentral applications where just everything happens on your own device. Especially if you like, let's say, go iPhone 14 plus onwards, almost certainly you can run some small model that can do some clever stuff. And you don't need to target that because you can target your laptop, in which case you can run Llama 3 8 billion, which is like almost as good as GPT-4 from last year, which is everything you ever need to do a lot of cool stuff. But just wanted to say that open source for the way. Go on. Questions?
All right, thanks, Michelle.
Thank you.